This question says a force F equal to minus k by I plus xj, where k is a positive constant, acts on a particle moving in the xy plane starting from the origin. The particle is taking along the positive x-axis to point a, 0 and then parallel to y-axis to point a. The total work done by the force F on the particle is. So let's try to represent that graphically. So this is, let's say, x-axis, this is, let's say, y-axis. Now the point from where I'll take this point to be a, 0. So initially it is taken from this, and from where somewhere here this point to be a. So how is the particle moving? Initially the particle moves in this direction and then it moves in this direction. So let me convert this question into two parts. That is when it is moving from, I'll say, O to point A, then point A to point B. So what is force? I'll say when it is moving from O to A, what is force? F equal to minus k into yi plus xj. So during O to A, we know that what is y? Y equal to 0. So if y equal to 0, I can say force equal to minus k into xj. This is what is force. Now what is work done from O to A? F dot dr. That is equal to minus kxj dot dr is how much? Dr is ai. Now the dot product of j and I is how much? 0. So the work done from 0 to a is 0. Now let's look at work done, force acting when it is going from a to b. A to b, what is value of x? X value is a. So I can write it as minus k into yi plus aj. This is what we have. So minus k into yi plus aj. Now what is dr or what is r? I'll say r is equal to the change in position, that is from 0 to a along y direction. So I can write it as aj. This is r. Now from these two, what is work done from a to b? A to b would be f dot r. That is equal to minus k yi plus aj dot aj. So that will give me how much? Minus ka squared. So what is the total work done? For the first case it is 0, second case it is minus ka squared. So the total work done equal to minus ka squared. So we used the dot product of vectors in this case. So the answer for this question would be minus ka squared, that is option C. Hope you could follow this. Thank you very much.